In story number 2, host A, the source, once again performs the Boolean AND operation to determine that its network ID is 10.10.10. This time, the destination IP address is 10.10.4.1, host X. Using the source mask of 255.255.255.0, the second Boolean AND operation results in a destination network ID of 10.10.4.0. The two network IDs are not the same, and the source realizes it can't send traffic directly to the destination. One of the golden rules of networking is that direct communication is only possible between devices on the same network. The source needs to get the traffic now to its default gateway, an interface on a router connected to its network. When a device is configured either statically or dynamically, in addition to an IP address and a subnet mask, that device also gets an IP address of a router interface on the network. That router interface is responsible for taking traffic off the network destined for other networks and bringing traffic from other networks back onto the network. We call that interface on the router performing those functions a default gateway, and its IP address needs to be known by hosts on the network. Routers are the devices that connect different networks together, and each interface of a router connects to a different network. Even though host A, the source, determines that the traffic is remote, it will once again send an ARP request, which is broadcasted to all devices on its network. This time, the ARP request is looking for the MAC address of host A's default gateway. In our story, we'll say the gateway's IP address is 10.10.199. The gateway will send its MAC address in a unicast ARP reply back to host A. Host A now sends the traffic with a destination MAC address of the router and a destination IP address of the actual destination, which could be 2, 5, 10, or more routers away. Incidentally, routers never forward broadcasts to other networks. Router interfaces will hear broadcasts on the networks they're connected to, but will never forward broadcast traffic from one network out of another interface to a different network. If they did that, a simple broadcast could go around the world and back. Just to understand our topology, a map or diagram of the network, you'll notice that each interconnection between router interfaces, including the router interfaces themselves, is considered a separate network. That means every device between router A's right interface and router B's left interface, including those interfaces, is on that shared network. The network identifier would be 10.10.2.0 if the subnet mask was 255.255.255.0. And all devices on that network would need an IP address starting off with 10.10.2. The last octet would be the host octet. Following the IP addressing rules we've discussed, every device on a shared network starts off with the same network identifier. In this story, we'll just make it easy and make the subnet mask for all devices and networks 255.255.255.0, which means all hosts on each network will share the same first 3 numbers, or octets. The last octet will be a host identifier for all networks. Everything between router B's right interface and router C's left interface is a network. That network identifier is 10.10.3.0. Our last network in this topology is everything to the right of router C's write interface, the 10-10-4-0 network.